Fundamentals of programming. Here we go. So first, I'm doing this in TypeScript. Reason why I chose TypeScript is just because, it's easy, not very complicated. It has some weird stuff with it, but it'll get the point across. And these fundamentals are through almost every programming language. So no matter what language you use, it won't change anything. You will find the same things between languages, and you'll learn, or you'll know the fundamentals of how to actually write code rather than the fundamentals of a specific language. But anyway, I have to choose a language to show this, so I just did TypeScript. So here, main function. Okay. The main function is not needed in TypeScript, but most languages you will find a main function. A main function is where your program starts. So anything inside of this is going to be ran. We're explicitly calling the function. This is a function call. But most languages wouldn't need that. In Python, you would also have to call it, but in languages like C, C++, Rust, Java has its own kind of main. All these languages, it gets called by default. You don't call it yourself. But here we do. So when we're writing a main function, right, you're writing whatever syntax, you're calling it main usually, and then here we're doing the actual code, what gets ran. We've got console.log. This is similar to Python's print hello world or any other language. And if we run this, bun main.ts, we have our hello world. So let's move on from not functions. Let's move on from the main function. Later on, we're going to go through actual functions. But first, let's talk about variables. So a variable, the way I imagine it is you're saying, actually, let's go with a classic. There's a common example where a variable is treated as a box. Imagine a box, right? And you've labeled that box. In this case, we've got a box labeled with the letter X, right? And in that box, we store some values. Here, we're going to be putting in 0. So literally the number 0, right? So it's kind of a word association game. You've got a name that is equivalent to a value. And that name that contains the value can have that value be changed. So the name can have now a value times 2 of whatever else. It can have a different value after the fact for a variable. Okay. We can also see this right here. We're creating the variable, that's this let x. We're not going to worry about this too much right now. This is a type, but we'll talk about that later. Then we have the equal to 0. Okay, so we're saying, hey, I want to make a variable called x, and I want to give it the value of 0. And then we're printing it out. Printing it out, again, means this, what we did there. And then here, we're reassigning the variable. We're giving x a different value. We're changing it from 0 to 1. And then we can print it out again. Let's try that first. Let's see how that looks. So we have bun. By the way, if you're curious what bun is, it's a TypeScript, JavaScript transpiler thing. You could use Node or Dnode, doesn't matter. I just didn't want to set up TypeScript, so I'm going with bun. So we do bun variables.ts. Oh, I didn't call the main function. So we do run variables.ts, and then we see 0 and 1, which is what our values are, right? X is equal to 0, X is equal to 1. And we're printing it out each time after the fact. If this is a little confusing, remember that everything is written line by line, right? Everything gets executed in order. So you kind of can see here, I've got some curly braces and some code in here. We can also do a little printing for this one. You're just going to now see an extra 1. There you go. But the reason why I've set this up is because variables is also tied to another concept called scopes. So in here, this is a scope. From here to here, that is a scope. All that means is whatever's inside a scope can't be accessed outside of its scope. It will essentially go away. It will vanish, it will disappear. So we can see this here because I'm going to get an error. There we go. Right, so inside of this curly braces, I've created a variable y, right? I'm doing stuff to y, but I can't do stuff to y outside of these curly brackets because this variable no longer exists. It's only available within this curly bracket. It's the same for this. If I went and wanted x and I wanted to change it, it can't find x because x lives within this block of code. I'm going to comment that out again. With variables, there's also another thing. Constants. So there's a few different ways to view constants. There's a constant value, which is a compile time known value. All that means is before the program's actually running, that value already exists. As opposed to the variable only existing, like the value of the variable only existing while the program's running. That's runtime. Compile time is before the code's even running. But we don't have to worry about that. That's beyond this. So there's that constant, but there's also immutability, or an immutable value. Immutable values are ones where you cannot change the value after the fact. So with this, if we comment it out, we can console log it. It's the same as above with this code. But this const is saying, hey, we're not allowed to change this value. I just want to have a value that might have been computed a bunch and all these things, or I don't want to retype every time, so I'm gonna give it a name, and I'm not gonna change its value. So if I were to do that, it would say cannot assign to x because it's constant. So that's variables and constants. One thing that I forgot to mention before we move on to functions is anything inside of this scope, right? So code in here can see values from here. So I can also change x to be whatever number, and this will work fine. But anything inside here gets removed, vanishes once we hit this curly bracket. Afterwards, it is no longer accessible. But inside of it, this stuff, these variables, anything over here is still accessible in here. Okay, so functions. So here we've got a main function, right? This time there's a type with it. You can see void. Don't have to worry about that. For now, I'll explain that in a second, but let's look at the actual inside the body of the main function. We've got let num, right? So we're creating a variable called num, and we're assigning it to add. And add, we can see these this 10 and 15. We're not, let's say we're not sure what this is yet, so we'll go over to this function. We'll look at its definition. It has a function that's called add, right? And anything inside of these brackets, right? Anything inside that is called a parameter or parameters or arguments. They're used interchangeably. It just means values being given to a function. So here we're giving x and y. They're both numbers, so we can do some math on it. And here, this might be a little bit of a more, not really more advanced concept, but not every programming language has this. This is a default value. And I'll explain this one a bit later. But let's leave it for now. We've got x, that's a number, and y, that's a number. And this part here says that this function is going to give back a value. It's going to give a number. So that when we create a variable, it is going to take whatever that it does, whatever math it's going to do, which here it's called add, I think you can assume what it does, and it will then give that value into none. It will put that value into the box. So let's go back inside here. Let's look what it actually does. So we don't know what this is yet. Let's look at x plus y. So we've got x, which is a number, plus, which is literal mathematical plus addition, y. Okay, so we can imagine 10 and 15 being replaced with x and y. So this would become 10 plus 15. And if we do the math for that, that's 25. So what does return do? Return says, hey, I want to give back a value. This is the value that we're giving back. Whatever this is, that's what we're going to give back to whoever called us. So this was called, this variable called add went inside here, it did the math, it got 10 and 15, and it got 25, and it's saying, okay, cool, let's give that back. And then that kind of gets replaced with 25. Now, you can see I have a console log over here that's saying it's never going to print, because once you've returned a value, you stop execution of that function. So if I uncomment this, you can see here it grays out and it goes unreachable code detected. So even if I run this function, this print statement will never run. It will never say never going to print, because we've returned out of it. We will go inside of this body and be like, okay, calculate this. Okay, return, bam, we're getting out of here and back over here, assigning it to here and continuing on. So once you've returned, you can't run code after it, with an exception of if statements, which I'll show in a second. So let's come back here and let's actually print it out. So we can do bun. Actually, let's clear it first. We can do bun functions.ts, and it's 25. Now let's look at this. So here we have, right, 10 going into x, yeah, but then we don't have a y. There's no y here. There's no extra number being passed to this function. So going back to that equal to 1 being a default value, what that kind of means is you can imagine it like that. It will insert a 1 in place of nothing. So when that happens, now this is being done as 10 and a 1. We go into here, this becomes 10, not 100, 10 and 1. So if we print that out, there you go, we get 11. Okay, let's now go to the if statements. So in programming, we have a type called a Boolean. A Boolean just means that this value is either true or false. So we're not going to look at this just yet. We'll look over to the main function. We'll start in the main function. That's how most of these things go. So here we have an if statement. An if statement takes a condition, which takes a Boolean. So if whatever is between these brackets is true, it will run this code. So here we have if true, and you can see this will always print, and it will always print because this value is true, literally true. This one, however, it's saying if false. Remember, this, whatever's inside of these curly brackets, so this code right here, will only run if this value is true. Since we've put in the value of false, this will never run. Unreachable code detected. Now that's not an error. You can do this. And same with that return from earlier, how it was unreachable. Technically not an error. You can put that there. But just good to know. So here, this is probably a better example of what you would see. And I'll explain this exclamation mark as well. But first, let's look at is Monday. Now, you can see it's Wednesday, but I'm not going to write the actual code to get the system dates and all that. I'm just going to put false. But yeah, we have got a function call, right? We go over to here, receive, that's the function name. It returns a Boolean. Specifically right now, it returns just false and always false. So remember, this thing is only run if it's true. So this code wouldn't run, right? You know what? Let's run it. Let's go bun ifs.ts. So we've got that this will always print, which is true, right? True. So this will always print. And then we got it isn't Monday, which is this code. You should probably have guessed it right. Like it's something with an exclamation mark. If you don't never run any code, the exclamation mark means the reverse, the inverse, or whatever of that value. So if you did that, exclamation mark true, this will print and say false, right? So it will just swap it. If it's true, we'll swap it and it will become false. If it's false, then it'll swap and become true. Some languages don't use it as an exclamation mark. Like Python uses the word not. Same exact thing. Now with earlier, how I mentioned sometimes you can have a return and it will continue code execution. Well, this would be the perfect case. So if you have an if statement that doesn't evaluate true inside here, well then this return will never run and you won't return out just yet. So you would be fine to put one here. Let's say if I had a value equal to false and I change this out so I get rid of that error, you can see we're all good. If it was true, then this will always run and will never hit this. And we can see that in action. See how this one print, but the it isn't Monday didn't print? Because this was true, so we left early. We exited out of the function early. Okay, let's go on to loops. This is where it gets a little bit more complicated, but we'll take it step by step. Let's first look at this. So with this, we're creating a variable called counter. right? Now we have what's called a while loop. A while loop is similar to an if statement. They're very similar. It's both the keyword first, right? So if and while, and then they have the brackets, and then they have the condition or the Boolean. And here, it again also will keep running whatever in between these curly braces, whatever the body is. It will keep running it, and as long as this is true. So here, this would only do it one time. This if statement says, okay, is this true? Run this code. Then we leave and we go over here and continue from here. But the if statement will keep on running the code body as long as this is true. Once this becomes false, once counter is not smaller than 5, then it will stop printing and stop whatever code is in here. And then it will move on to the next things of code. So here we've got counter equal to 0. While counter is smaller than 5, we're going to print it. So first it'll print out and be 0. And then this operator, the plus plus, is equivalent to saying counter equals counter plus 1, which is also can be written as counter plus equal 1. You don't have to worry about all that. As long as you remember that you can do this, that you're allowed to go counter equals to counter plus 1, you should be fine. You'll eventually start writing it more like these two, but not every language has the syntax like this. It depends on the language, but pretty much every language you can do that. So it will increase by 1, which means that this now becomes 1. Then we'll see, okay, is 1 smaller than 5? It is. We'll print 1, right? Then we'll increase it again. So now this becomes 2. 2 smaller than 5? Yep, print it. Becomes 3. 3 smaller than 5? Yeah, print it. Becomes 4. 4 smaller than 5? Again, it is. Print it. Becomes 5. Is 5 smaller than 5? 5 isn't smaller than 5. So we don't print this. We don't run this. We skip over to the end and we start running the next bits of code. And we can see that as well. I'll put a return here. And we can go bun loops.ts. So we got 0, 1, 2, 3, 4, and we didn't print 5, and we left because of the return. Now, another way of writing this exact code is to write it like this. There is a reason why you have a while loop and why you have this kind of loop. And it's mainly for, this is mainly for iterative numbers. So like here how we have a counter, right? And we're checking if the counter is smaller than a number and we're increasing the counter. This loop is specifically for that. Well, more used for that. This while loop can be used for that as well. Or if you need this value outside of the loop as well, you can do that. Or if you need something to run forever, you can put a true and I'll do that. Or if you had a Boolean here, like, I don't know, like this, and then you had if some function, then value equals to true, false, and we remove this with value, then it would eventually become false and it would stop running the code. But anyway, let's go on to the for loop. So a for loop, you can see there's a bit of jumbly characters here, but let's go over it one by one. So this first bit is creating a variable. Same as this. but one difference. This variable only lives within the scope. Outside of the scope, you don't have I anymore. So I can't just do console.log I, because it doesn't exist. It's gone at this point. But inside here, oh, I was printing counter, actually. I meant to print I there. But yeah, here you can see you can print I. So this creates a variable to start. That part is always creating a variable up until the semicolon. Then we have the condition, same as this, right? This one's saying the same thing. While it's smaller than 5, we're going to keep running this scope, this code block. And then after that semicolon, we have I++, which increases the number by 1, which is the same as this. There is a difference between this and this, though, and we'll see that later. But effectively, these two are the exact same. Besides the fact that this value can be used over here and here and here, but this value can only be used inside of here, inside of this scope. Okay, now one of the reasons why we use for loops is for arrays. We haven't gone through arrays yet, but you'll see what they are in a second. I'll explain it really quickly. Arrays contain multiple values. So how counter is only the one value, it's a box with just 0 in it. This array is a box with more boxes inside. And inside those boxes, they have numbers. So we have, it's basically a list of numbers. So it's got 1, 2, and 3, right? And then we can iterate over it. We can go for loop while for I equals to 0, I smaller than numbers, not length. This is different when different languages, but the length of numbers, this variable, is 3 because there's 3 numbers in here. We increase I and we'll index into the array. Indexing means we're going to grab out each value one by one. So where this type is a number array, this type is a number, because we're using the I to take out each individual number inside of this list. Now, you can also see that I is 0, so we're doing numbers at 0 first, and that is correct in this language. This is something that is on a per language bias. I don't know if that's the right word, but in some languages, the first element here, this 1, would be at position or index 1, and in most languages, it's 0. But that doesn't matter too much. You just need to know that you're able to index into an array, usually through this kind of syntax. Not always, though. But this is saying, hey, we've got the numbers. I want to grab out I want to grab out this position number, which if it's 0, it'll be 1. So this one would then become 1. And then later on, it'll become 2. And then later, it becomes 3. And we'll print it. Let's do that as well. Let's run this code. That was maybe bad. Maybe I should have formatted it, but you can see 0 through 4, which is this one. And then we have, again, 0 through 4, which is this one. And then we've got 1, 2, 3, which is this one. Now, a lot of languages nowadays also have a different way of doing this. Like, they will have this kind of way, or it will be like this. if you want to grab out each number from an, or each value from an array. But a lot of the languages now have, it's called a for each loop, or a, well, I think that is the name. It's a loop where you're just taking out each number directly in the loop, directly in this part, not inside of the function where you have to index into it. It will just get it for you. So this code is the exact same as this code, like purely the exact same. This one's saying create a variable n of numbers. You'll also see this like in Python be for n in numbers, or actually that's pretty much most of the cases you'd say like that, or you might see it as for each, and it'd be like n colon numbers. I think that's also something. You might have to do the type here like that, or it depends on language, but they're all effectively the same. It's saying, I want you to just do it for me. I'm going to grab out each one. I don't need a lot of control. I don't need to have the number. I just want to grab out each value from an array, from a list, from a thing that collects multiple values. So we'll comment this back out. And this is the last thing about loops. And actually, we'll comment all of this out. So we'll just focus on this. So again, we've got our for loop with creating a variable, making sure it's smaller than 5, increasing that variable. But here we've got some things. We've got these two keywords now, and we've got some if statements. So here we're saying if I is 0, we're going to continue. What continue means is I don't want to run any of this code. I want to skip over to the next bit of the loop. So if it was 0, which means the first time we're looping, it's going to say the continue. It's going to be like, okay, we're not going to print 0. We're not going to check if it's 3. We're going to increase this to 1, and we're going to go again. Is it 0? It's not 0. We'll print it out. And then we'll check, is it 3? No, it's not. So we go over here, and oh, that's the end of the loop. We'll go back to the top. Now, this will increase, so this becomes 2. 2, right? Not smaller than 5. Not 0. Print it. Not 3. Continue. We go to 3. So now it's 3. 3 smaller than 5? Yeah. 3 is not 0. Cool. We print 3. And then we get to here. 3 does equal to 3. So we break. I think break makes sense. It's saying we're breaking out of the loop. We're going to exit the loop now. So from here, we're going to go over here and continue, continue doing some code, right? And yeah, we can see that in action. So if we run it, we get 1, 2, 3. But if I did this, and I did console.log I, and I removed all of this, oh, I got too many. There we go. But see, normally it'd be 0 to 4. But with those in place, with those if statements and the continue and the break, it only prints. Oh, because I left this one in here. It only prints 1, 2, 3. Cool. Now this is the last one. We've got types. So we're going to ignore all of this up here. Maybe I can do that. Nope, maybe I can do that. Cool. So back into the main function. Here we've got the Boolean actually showing the types now. Kind of rearranged, I've kind of ordered this in a weird way, but those are Booleans, right? This is the type. that's true, that's false, that's the two values of a Boolean. You can also do equality checks. So if true is equal to true, this will be true because true is true. If you did true is equal to false, this comparison appears to be unintentional because the types true and false have no overlap. Well, yeah, normally you wouldn't write this code. So maybe they're just erroring because of that. But true does not equal to false, so this would evaluate to false. So this would become false. And then you can do false is equal to false, which becomes true. And you can have not equals to false, or not equals. How we saw earlier with the not is Monday. It's the same thing, but with an equal sign. Okay, here is the array. So arrays, you can say the type here. So this is the subtype of an array. So you could have an array of booleans, and then you'd make this true, false, false, true. That works as well. And then with arrays, you can also get a length. In Python, for example, that would be len, and then you would put numbers. In TypeScript, JavaScript, it's numbers.length. In other languages, it's also a bunch of other things. You would maybe see a dot length like that on numbers. You would see, maybe in some languages, there's not even a proper way to get the length, like in C. It depends. But usually you'll be able to somehow have a length. And that's good for looping. So here we can print out the numbers, which will print out like this, and then the length, which will be 3. I don't know if you can do this. Can you do that? No. Okay. So this is a string. We've seen some strings, right? We look back at the main function. This is a string. So this is a string literal, right? So its type is string, its expression is a string literal. The only reason for that distinction is because these are also literals. These are integer literals, but you could change that to be something else. You could have x there and put x in here, and that works as well. These are all expressions. As long as it's an expression, it can be a value. So we have our string that's equal to hello, and we can print it out, and we can also, don't mind the syntax. There's different ways of doing this in different languages. All you need to understand is this part where it's white is the actual value. So it would change this part with hello, and this one will just be an actual string. It will just say letters, colon, space, hello. And then the length, we can also do by letters.length. Say in Python again, you can do len brackets letters. And let's run that first. I'm going to comment all of this out. And we're going to do types.ts. There we go. So we've got numbers, 1, 2, 3, right? 1, 2, 3. And it has a length of 3, which is right. Then we have, oh, did I say letters? Did I say numbers? I might have said letters. Here we have letters, and it's hello, which is correct. And then we have the length, which is 5, and we can count that up, right? That's 1, 2, 3, 4, 5. So yeah. Now this is where things get a bit more interesting when it comes to programming. You can create your own types. So to create a type, you would need another type. And we'll see that here. This is the code for it, but we won't look at that first. We can actually. No, we won't. We're gonna look at this. So we're gonna go up here. Here we've got a class. Now there's a few different ways in JavaScript and TypeScript to create types, and this is just a simple, like, it's what you would probably most commonly see. Also, mind you, classes are not in every language. They may be called structs, which may behave similar to classes. They may also behave slightly differently. It's a matter of the language, and also a matter of the semantic choices of that language. But most of the time, in pretty much every language, you can make variables. Sorry, you can make types and do things with those types. And if not, you can create types and do things with the data, and they're all of the same type, kind of thing. So here we've got a class. You can imagine this being the word type as well. That's fine. This is a whole spiel of other things as well, which is not related. This is called object-oriented programming. Well, you don't have to have classes to be object-oriented, but very common. And then we've got the name of the type, and we're calling it point, like a 2D space point, like this point over here and that point over there and this and that and that and that. And then we've got the x and y coordinates, or points. So we've got x, which is a number, and y, that is a number. We don't have to worry about this too much, but this is a way to create or construct the type by giving it some values. So we can take in, this is kind of like a function like we've seen before, but these are called methods here. There's not too much you need to know about it. And I can explain, will explain a bit more. So a constructor will take in x and a y, which we can see down here even, right? We've got point. It's kind of being called like a function because this is a function. And we're providing it 10 and 15, right? So x is 10, y is 15. And we're saying this dot x. Now, we're not going to worry too much about what this means and why it's red and why it has an x. But you can imagine it as this dot x is this number over here. This x is this number over here. So when we're referring to this x, we're doing this dot x. And we're referring to this x, we're talking about this one. Okay, so same thing here with the y. And then we have this other method, this other function called add, which takes in another point, right? And what this does is saying we're going to increase this x with that other point. Same for the y. This y gets increased by this other y. So let's see this first, right? Over here we have let p1, so point 1, equal to new point. We don't have to worry about new too much. Depends on the language. But we have a new point with 10 and 15. So this point has an x of 10 and a y of 15. Then we've got another point, p2, that is a point of 12 and 50, right? So the x is 12, y is 50. Now we have this syntax, which I don't think we've seen yet. It's like a function call, but we're doing it on a variable. So this variable p1 dot the function name we had up here. So this p1 dot add other, right? Other. So we're passing in P2 as the other. And in this case, this refers to P1. If we did P2.add P1, this dot x, right? For this, let's comment this one out. We're looking at this one. In the case of P2, this dot x in this function would refer to 12. Same thing for the y. It will refer to 50. In this case, with P1.add, this refers to 10, and this y refers to 15. Okay? And then other would be P2. So other.x is 12, and other.y is 50. And we're adding that value onto this dot y. So when we run this function and we print out down here its values, p1.x, p1.y. Also, the way that this works with the dots, you can imagine it kind of like an array. It is accessing one of the variables, one of the values within P1, because P1 contains multiple values, and they're named values, so you can access them by name, doing dot their name, dot their name, instead of an array which is accessed by a position, by an index. These have named values, right? So here we're printing out P1's x and P1's y. So we can check this out. Let's also go ahead and comment all of this. And there we go. We get 22 and 65. Let's check if that's right. Here we have 10 and 12. When we're doing add, we're doing 10 and 12, which is 22. Then we have 15 and 50. So 15 plus and equal to, right? Remember, that syntax is the same as saying equals to this dot y plus other dot y. So 15 plus 50 is 65. And we're making that equal to this dot y. So this dot y is now 65, which is correct. So that one's a bit more confusing, and you don't have to write code that way. I've got this example over here, which does the exact same thing, but just different syntax. A lot of things in different languages or even within the same language can all be achieved and all be done in a variety of ways, and they don't matter too much. Well, that's depending on the argument. If it's like talking about your algorithms and your data structures and stuff like that, and benchmarking and testing, then yeah, it matters. But when it's something like these two cases, these two lines of code, this is just a syntactic choice. There is no difference between these. So here, I've commented this one out and replaced it with a function call, point add, where I'm passing P1 and P2. So we've got that function here, point add. We have a self, which is this point, P1, right? And then we have an other, which is P2. And then we're doing the exact same code as this one. We're taking P1 and increasing it by P2 for each value, each x and y. And then we're going to print it out again. And you'll see it's the exact same. There is no difference. So these two functionally the same, but different ways to do it. So that is all of the fundamentals. That's pretty much everything you need to start writing some code and making a little project, I think that's a good thing to do. Just with all of this in mind, which is not a lot of things, and even though you may not understand all of them or haven't used any of them yet, having the idea, if you haven't written your first project or made something silly, there you go. You've got all the building blocks, you've got all the fundamentals to just create something. It doesn't have to be good. It doesn't have to be revolutionary. It just has to be something, you know? And that's all you need. That's literally everything you need. You could make pretty much with just this and just this alone, you can make an operating system. You can make a game, even. Like, of course, there's more complicated stuff and things you would have to learn on the way, but everything revolves around these things. So if you got that down, you're good, you're golden, you're spick and span. These are the things that are used everywhere between pretty much every language. So there you go. This one's been a bit different to what I usually do. If you like it, let me know. If you have anything that you wanted me to talk about in the video, but I forgot it or missed it, or if you want some clarification because I was bad at explaining something, please let me know. And yeah, thank you. See ya.